Okay, thank you, Kirsten. Good afternoon, everybody. Hope you're staying safe and healthy during this time. My name is Artem Larionov. I'm marketing expert in Rosatom overseas. I'm in charge of promotion of SMRs and floating nuclear power plants on foreign markets. It's a great pleasure for me to attend this webinar. I would like to thank the organizers, European Nuclear Society, for kindly inviting Rosatom to this event. In my presentation, I will speak about the world's first floating nuclear power plant, constructed and launched by Rosatom, and about current activities of Rosatom in terms of SMR development in general. After that, we will have a Q&A session. I will try to ask questions, if any. So let me start with a brief overview of Rosatom and a few facts. And a few facts about our company. Rosatom is one of the leading energy and technology companies on a global scale. We successfully constructed and launched the first grid-connected nuclear power plant in the world. That was Obninsk NPP in 1954. Now we have about 30 gigawatt of installed capacities in Russia, and last year we attained a new record in electric power production, over 208 billion kilowatt hour of electricity, what makes us the largest generator in Russia. That is about almost 20% of total Russian electricity generated. I'm proud to say that we are #1 by NPP units in international backlog. Currently, we have 36 units in our overseas portfolio, and we also share 36% of global enrichment market and global extraction and global uranium extraction market.
Excuse me, Artem, we cannot see your presentation. We cannot see your presentation anymore. Can you check this?
Yes.
Is the presentation on your screen?
So now you see it? No?
Wait a second. I'm going to take back control and make you. Okay. I'm going to make you presenter again. Okay, sorry. Hope
okay,
now everything should be okay. Yeah.
Okay. So do you see the slide right now?
Yes, I can see it now.
So let's continue. Rosatom is the only company in the world to offer integrated clean energy solutions across the nuclear supply chain and beyond, including design, construction, and operation of nuclear power plants, uranium mining, conversion and enrichment, supply of nuclear fuel, decommissioning, spent fuel storage and transportation, and safe nuclear waste disposal. The global energy market is moving from commodity-based solutions to technology-based solutions, and small modular reactors can considerably change the paradigm of not only the nuclear power, but also the global energy landscape. They share all the advantages of conventional nuclear generation, such as environment friendliness, sustainable supply of energy, predictable electricity prices, with something to offer on top of that. Additionally, SMRs have their unique benefits. I'm speaking about easy grid connection, flexibility in terms of placement, multi-purpose application, including district heating, desalination, and possible integration with renewables. One more advantage of SMRs is that they offer lower capital investment, which can be a crucial point when making a decision about project implementation. So aside from the vast experience in design, manufacturing, construction, and operation of large-scale NPPs, Rosatom also boasts an impressive record of small reactor technology development for the icebreaker fleet, more than 400 reactor years. We now have 4 nuclear icebreakers and 1 nuclear light airboat ship carrier in operation. And since 1959, we launched and operated about 20 reactors. I'm proud to say that 6 state-of-the-art Rosatom series SMRs have been manufactured and installed on universal icebreakers, Arctica, Sibir, and Ural that are now being constructed. These icebreakers will have variable draught, and they will be able to navigate both shallow rivers and deep seas in the north. With the help of such universal icebreakers, we expect to ensure all year-round navigation across the northern sea route and increase the cargo traffic to 120 million tons by 2030. In November 2019, 2 Rosatom series reactors of Arctic icebreaker attained first criticality, and after entering service this year, it will become the most powerful icebreaker in the world, and it will be able to break through ice up to 3 meters. Sibir and Ural icebreakers with Rosatom series SMRs as well to enter operation in 2021 and 2022 respectively. And 2 more icebreakers of this kind have been contracted. Based on this vast experience of design, manufacture, and operation of small reactors for icebreakers, we developed the world's first floating nuclear power plant, Academic Lomonosov, named after a prominent Russian scientist. The plant will enable reliable, safe, and affordable energy supply and ensure sustainable development of the key industries in the destination region, Chukotka. It will replace PVEC's aging Bilibino nuclear power plant and Chaunsk coal-fired power plant, saving about 50,000 tons of CO2 emissions per year compared to current levels. FNPP is equipped with 2 Kel-T40S reactors and can generate up to 77 megawatt of electricity. The reactors actually are quite similar to those used on icebreakers. They were designed by Russian nuclear scientists and naval architects. The vessel itself is 140 meters long and 30 meters wide, and it has a displacement of 21,000 tons. The FNPP is designed for 40 years with possible future extension. The fuel cycle is 3 years, and once in a 12-year time, there's a shipyard maintenance that lasts 1 year. The FNPP is also able to operate in cogeneration mode and in thermal mode only as well. Now a few words about the status of the project. In April 2019, comprehensive testing of the reactors were finished. In June 2019, the operator of FNPP, Rosatom, that is a company that operates all the nuclear power plants in Russia. So it was granted an operation license by Russian regulator Rostechnadzor. In September 2019, the FNPP was successfully transported from Murmansk to PVEC and covered more than 4,700 kilometers. In December 2019, it was connected to the grid and started supplying electricity. And in January 2020, the FNPP delivered its first 10 million kilowatt-hour of electricity to the Chukotka grid. We expect to put the FNPP into commercial operation in summer this year when it starts supplying heat. The FNPP consists of floating power unit, hydraulic structures, and the coastal side. Let me start with the description of the coastal side. It includes a closed switchgear, which provides distribution and transmission to consumers of electricity. electrical substation, heat supply station intended for the preparation and distribution of district heating water to the consumers, waste treatment facilities, and utility networks. The coastal site is equipped with a checkpoint for access to the territory of FNPP and other elements of physical protection. There are video surveillance systems and alarms, as well as emergency communication channels. The complex of hydraulic structures includes a special pier with devices for unfastening and special underwater pit that creates necessary conditions for the operation of cooling systems of the power plant. This pier protects the floating power unit from the ice drift and waves. So I will make the full screen. Dams and breakwaters have been installed, making colliding with icebergs practically impossible, and coastal infrastructure prevents any possible impact either against the shore or the seafloor. It is located in a bay that ensures additional protection. The floating power unit itself is a non-self-propelled vessel that houses two KLT-40S reactors, spent nuclear fuel and solid radioactive waste storage and handling equipment, two steam turbines, main and emergency power systems, and the residential unit. When designing the academic Lomonosov of FNPP, we observed all Russian and international safety standards. The stress test conducted after the Fukushima accident in 2011 confirmed the high resistance of the FNPP to severe accidents, including tsunamis, wind loads, and other hazards. The safety is ensured by a combination of active and passive systems, inherent safety features, and defense in depth principle. There are 5 safety barriers. You can see them in the slide. First one is fuel pellets, and then fuel cladding, primary circuit, reactor containment, and special containment room. That is basically a system of cabins that have individual ventilation. Rosatom is now ready to offer to its potential customers energy solutions based on state-of-the-art Rusatom series SMRs that incorporate all the best features of their predecessors, KLT-40 ship reactors. Rusatom series SMR is based on time-proved pressurized water reactor technology and 40 reactor years experience of Rosatom in safe operation of small reactors. The technology has proven its efficiency and ultimate safety throughout all stages of the life cycle, including radioactive waste management. So now there are 2 options of Rosatom SMR solutions, the floating NPP and land-based NPP. Both solutions are based on Rusatom series SMRs. Let me give you more details about the floating NPP first, the optimized floating NPP. Well, FNPPs combine the traditional advantages of nuclear power with its unique benefits. I'm speaking about short period of construction works at site, long fuel campaign up to 10 years, no decommissioning at the site, flexible lifetime period and business models. And the main idea that we kept in mind when developing this product was to ease the burden on the potential customer to make it as easy to use as it could be. FNPPs can be considered for a wide range of potential sites, including islands, archipelagos, offshore facilities, various mining and mineral processing facilities, both in the north and in the south. What's more, FNPP can be quickly relocated to another site when needed. What makes FNTPs unique is that they are built from start to finish in shipyards using the same expert construction technology as on nuclear icebreakers and Navy ships. Following the success of floating nuclear power plant, academic Lomonosov Rosatom is developing an optimized version of the floating NPP based on two Rosatom series SMRs, equipped with two Rosatom series reactors, each of 50 megawatt. Compared with academic Lomonosov, it is more compact, more powerful, and more efficient. The electrical capacity will be increased from 77 megawatt to 100 megawatt. Fuel cycle from 3 years to 10 years, and design life from 40 years to 60 years. With possible extension, of course. The development of FNPP is now the concept design stage. Our flagship SMR incorporates all the safety features of the most advanced generation 3+ nuclear power plants. It can withstand various natural events like extreme temperatures, tornadoes, wind loads, and earthquakes. I can but mention the combination of active and passive systems that eliminate as many potential risks as possible, reduce the likelihood of accidents, and ensure that if an accident does occur, the consequences are minimal. It is important to understand that the possible damage to the vessel does not mean the damage to the reactor. And in case of capsizing, the reactor will safely shut down. Moreover, any direct damage to the vessel, such as a crash into a concrete pier or the vessel drowning, will not affect the reactor at all. Now, let me give you more information about Rosatom land-based solutions. So by now we have already developed a concept design of the land-based NPP equipped with two Rosatom series SMRs. The electrical capacity of NPP with two Rosatom 200 reactors is 114 megawatt, and scalable modular design is what makes this NPP a suitable solution for local energy needs. The capacity of land-based NPP can be easily expanded from 140 megawatt and higher by building additional main building and cooling towers, and auxiliary buildings can be shared to reduce the land use. Such NPP can be used for multi-purpose application, including electricity generation, district heating, hydrogen production, and it also can be a part of desalination complex. This plant occupies, well, a really small area of 15 acres. The availability factor is 19%, and the refueling cycle is from 6 to 7 years. So our flagship SMR incorporates all the safety features of the most advanced 3+ generation nuclear power plants. It is also able to withstand aircraft crash impact. It has a hermetically sealed envelope around the vessel, the reactor vessel, to localize possible radioactive releases, solid building core made of thick concrete walls, and collapsible building structure of reinforced concrete walls. In case of the loss of crew accident, our NPP wouldn't need the intervention for 72 hours. And in case of blackout accident, the unlimited period is provided till the automatic core cooling. So now I would like to say a few words about SMR NPP project in Russia. And here I would like to quote Director General of Rosatom, Mr. Likhachev. He said that an important, really important aspect of our foreign practice is that Rosatom always follows the principle. First of all, we build in our own country and only then offer reference technology to the foreign markets. So by now we have started the implementation of first of a kind SMR MPP in Russia. Rosatom is now considering several locations for placing the first MPP. Among the possible locations are Surayamsk deposit near Chelyabinsk, some sites in Yakutia, and Pishanka deposit in the Chukotka. And the main target for this year is to determine which would be the best site for our MPP. We plan to get the site license by 2023, license for construction by 2024, and during that year we are going to start the construction. And by 2027 we plan to connect the SMR MPP to the grid. Although undoubtedly SMRs are a solution, there are still challenges we need to overcome. First of all, to facilitate and harmonize the applied norms and regulations without any safety requirement reduction. Second, to implement the effective life cycle and business models. To develop a comprehensive energy solution for targeted customers. And we should use standard designs and factory prefabrication of large pieces of equipment. And the pathway to achieving these goals is a combination of challenges that have to be solved jointly by the international community, international organizations, vendors, and policymakers. And I think that the discussion should expand beyond the energy sector and involve cross-sectoral stakeholders. I mean that we need banks and financial institutions to ensure the financial issues of the project. We need venture investors to provide support to innovations that SMRs create. We need lawyers to provide assistance in building new regulatory approaches. And of course, the approach should be comprehensive, and the actions should start as soon as possible. Thank you for your attention.